Superposition theorem.
Welcome to another episode of Applied Electricity EE151 by King Solomon and Pekosi David. Today we'll be dealing with superposition theorem. Now, superposition theorem is also a theorem that will help you find a particular current or a specific current within or the current within a specific resistor. So now let's listen to the theorem and let's know how we can use the theorem to solve this question.
The theorem states that the current or the voltage across any element in a multiple source linear circuit can be found by taking the algebraic sum of the current through or the voltage across that element due to each individual source acting alone.
So now, the whole idea about superposition is that with superposition theorem, what happens is that we want to deactivate some sources. So take example, the voltage sources. So in superposition theorem, we only want one source or a voltage source to be acting at a goal. So at a goal, we want to find the amount of current a particular voltage source will act or will give out. So in this particular question, we want to use the idea of superposition theorem to solve this particular question. In this particular question, we are having two voltage sources over here. That is 42 volt source and 35 volt source. And we have to find the current within this 3 ohm resistance. So there will be a total current that will flow through this 3 ohm resistance. Now this kind of current that will flow here, some of this current will be from this part and some of this current will be from this part. So the effective or the amount of current or the total amount of current that will pass through this 3 ohm resistance is what we want. It's what we want. So now, what do we do first? We want to deactivate one of them. So we are deactivate the 42 volt resistance and the 35 volt resistance will work. So now, in the first instance, what we do is that 35 volt acting alone. So if the 35 volt is acting alone, then we have 12 ohm, 6, 3 ohm, and then 35. Sorry. So, like as I said, this one produces some current through here, this one produces some current. So we want to find the resultant current. So the resultant current that will pass through this 3 ohm resistor. So now when the 35 is acting alone, what happens is that there's a current that will be produced in this direction. So let's say this current is IA. So now I want to find the current the 35 will only give if the circuit was this way. If only 35 volt was active, I want to find that current that will be producing. So we know that this current will come here and the IA might split into maybe I1 and I2. So now IA will be the current this 35 volt will produce to pass through the 3 ohm resistor. So now how do you know the IA current? So to know the IA current, we understand that this 12 and they're having different currents passing through them, so they are parallel. So the 12 here is parallel to the 6. If it is parallel, then the resultant or effective resistance becomes 12 times 6 divided by 12 plus 6, which will give you 4 ohms. So the effective resistance between this 12 ohms and this will give you 4 ohms. If it's giving 4 ohms, then now this 4 ohms resistor will now act 3 ohm resistor, 35 volts, will now act in series with this 3 ohm resistor. But so the current that passes through the 3 ohm resistor is I. So if it is acting in series, then the total effective resistance. So the total effective resistance now becomes 4 ohm plus 3 ohm, which is equal to 7 ohm. So if you want to find the current IA, the current IA is simple as it goes. I is equal to V, IR is equal to V. So I is equal to V on R. So that is 35 divided by 7. So current IA is 35 divided by 7. And 35 divided by 7 is simple 5 ampere. So when the 35 volt is acting alone, it will be producing 5 ampere. That is 5 ampere of current to pass through this 3 ohm resistor. Now let's deactivate the 35 and the 42 to also act alone. So now we come here, 42 volts acting alone. If the 42 volts is also acting alone, then what are we getting? So we draw the diagram, the 12 ohm, the 6 ohm, the 3 ohm, and the 42 volts. Okay, so now what we get here is that the same here to the 42 will be producing a certain amount of current. So let's call this current can be, let's say this current is I. Now, when this current gets here, this current was split into maybe let's say I1 and I2 at this very junction or node. So when the current split at this junction, the amount of current produced by the 42 volts that will pass through this 3 ohm resistor is I1. So now our focus here is to find I1. How do you find I1? Here. Now we can easily find the total current that is passing through, or the total current that the 42 volt is producing. Now before that, let's find the effective resistance. Now to find the effective resistance, you realize that these 6 and this 3, they are parallel to each other. So the 6 ohm resistor is parallel to the 3 ohm resistor. So if it is parallel, then the effective resistance is 6 divided by 6 plus 3, which is 18 or 9, which gives 2 ohm. So now if it's given 2 ohm, these two resistance, the effective resistance will now be in series with this 12. So now the total effective resistance in this circuit, now becomes the 2 ohm plus this 12 ohms, giving 14 ohms. So now if the total effective resistance is 14 ohms, then we can now find current I1 and current I2. Now remind you that we did current division law. So the current division law can help us calculate the current through this one. And now the total current that is coming here, how do we do that? We can find the total current as well. I is equal to 42 divided by 40, which is equal to what? Which will give you 3 ampere. So now the total current that is being produced here is what? Is 3 ampere. Out of this 3 ampere, we want to know the amount of the 3 ampere that will pass here and the amount of the 3 ampere that will pass here. So now we can say that from KCL, Kirchhoff's current law, we can say that I1 plus I2 will give you 3 ampere. Okay, when you know this, we can use current division rule. So the current division rule to find the current that will pass through here. So now therefore, if we want to find the current that will pass through here, I1, from current division rule, I1 is simple what? We take the opposite voltage. So now that is 6 ohm divided by the summation of the the opposite resistor. So 6 ohm divided by the summation of the 2 resistors times the total current, which is 3 that is coming. So when you do this, you get 6 on 9 times 3, which will give you 2 ampere. So the current I1 will give you what? 2 ampere. So now when you come here and want to find the resultant current that will pass through this 3 ohm resistor, then the resultant current is simple. We have a current that is coming downwards and that current that is coming is the I1, which is 2 ampere, and you have a current that is going upwards like this, which is the IE as 5 amperes. So therefore, the resultant current I that will pass through this 3 ohm resistor is simple IE minus I1. Why? Because we are moving in opposite direction. So the I now becomes 5 ampere minus 2 ampere, which is 3.0 ampere. So now this is how the superposition theorem is done. So if you want to find a particular current passing through a certain resistor, you can either use what we thought earlier on, the Thevenin, the Norton, or the superposition theorem. There's another theorem which in a different class or a different episode, and we deal with that theorem. It's called the reciprocity theorem. Thank you very much for joining us for this episode. Bye.